Hello everyone, welcome back to another video. In today's video, our takeoff will be a bit different because the internal walls and the external walls are different in terms of structure. The external wall is a cavity wall, while the internal wall is not a cavity wall. It's a concrete block wall. The external wall, the thickness of the foundation strip is 775 millimeters, but that of the internal wall is 600 millimeters. So when you're given a plan whose internal width, the internal walls are different from the external walls, how do you do the takeoff? That is the main question. If you're new to this channel, this is the channel where we prepare students for exams, especially in estimation and costing. So you are at the right place if that is what you're looking for. We have been doing videos of different taking offs, and we usually deal mostly with the questions that our subscribers ask. So if you haven't subscribed to our channel, kindly subscribe, and any question that you'll be asking shall be answered. This is one of the questions that have been asked. What if you're given walls whose thickness is different from the internal walls and the external walls? And today we are going to answer this question. If you like this video, kindly remember to give it a thumbs up and continue to show support to our channel so that we can be able to make this content for you and for free. So welcome to our channel, and I will hope that you will learn as much as possible, and you shall our channel shall enable you to prepare for exams in the fastest ways possible, because it always tries simplifying questions for you, and we simplify concepts for you so that you can understand in the simplest way. So in today's video, there are two questions that I will leave you as assignment. So be keen and let's learn together. So in our video, you can see on your screen, we are given the plan and the sections. The plan, 13.5 meters, and the width is 6.78 meters. The internal length and width is 3.7 and 3.5. We have section AA and section BB. All right. Section AA, the foundation spread is 775 millimeters wide. You see, this is the foundation strip. The spread is 250 millimeters for this side and for the other side. Then we have 150 millimeters plain in situ concrete, ratio 1:4. Then here we have the ground level, which is made up of farm clay. So when you're told farm, is there any need for site clearance? We haven't been told that there are shrubs or bushes on site, so that we shall not do site clearance. Then you're told it's farm clay, so you will not do removal of vegetables. So good. So here we have 150 millimeters to damp proof course. Then we have the 150 millimeters hardcore bed. It's here. Then the depth from the hardcore to the foundation strip is 900 millimeters. We have the 50 millimeters insulation, and we have the 100 millimeters reinforced concrete bed. You need to study these diagrams before you start taking off. We have the 275 millimeters cavity wall. So this wall is 275 millimeters thick. Then on the outside, externally, we have the facings and common bricks internally. Then we have 50 millimeters cavity with concrete fill, ratio 1:12. The bitumen damp-proof course. Then 50 millimeters rigid cavity insulation. That one we have seen. So we go to the internal walls, section BB, whereby we start with the foundation strip, which is 600 millimeters wide. Then we have the 150 millimeters plain concrete in situ, ratio 1:4. 1:3:4. Then we have the 900 millimeters depth. Then we have the 100 millimeters dense concrete block wall in cement mortar, ratio 1:3. The hardcore and concrete bed is a section AA. This is a question that we have got the quantity surveyors guidebook. It's called the quantity surveyors handbook. So this is a question that they have solved, and all I will do is explain it. All right. For this takeoff, we shall begin with oversite excavation. The oversite excavation, to calculate the length, we will take this 13.5 for the external length and 6.78 for the external width. Then we shall add the spread. You see the spread for the external length is 250. So 250 on both sides, we shall get 0.5. So we shall add 13.5, we add 0.5, we get 14. So the length we shall excavate to reduce level is 14. Then we find the width. The width was 6.78. We add 0.5 to 50 on both sides, we get 7.28. So 7.28 for the width. Then the depth, to what depth shall we reduce the level? If this is the ground level, so the ground level was here. What level will we reduce? So that you know you will reduce the level so that you can be able to lay the hardcore. And we are told it is 150 millimeters hardcore bed. So we shall reduce by 0.15. Excavating in reduced level, maximum depth not exceeding 0.25. Why are we writing 0.25? Because in SMM7, we are told if the starting level of the trench excavation is over 250 millimeters below the existing ground level, then it must be stated in the description. If it is not above 250 millimeters, we shall write not exceeding 0.25 millimeters. Okay, so the next step is excavating for the trenches. Okay, to excavate for the trenches, we need the main guard. How do we calculate the main guard? For the main guard, we take the length, 13.5, the width, 6.78. Remember, to calculate the main guard, we take the external perimeter, then we deduct number of corners times the thickness of the wall. So the perimeter is equals to length plus width multiplied by 2. So we shall get the perimeter as 40.560. To deduct to get the main guard, we shall take 4 corners, then we multiply by the thickness of the external wall is 0.275, the one we have got here on the section. So 4 times 0.25, we shall get 1.1. You could ask yourself, what is this 2 times a half? I have done a video which explains about the main guard, how to calculate the main guard. So if in your aren't conversant, kindly find the link in the description box and kindly find that video, because you need to know how to calculate the center length before knowing how to take off, because you will need this center length when you're taking off. So we shall take the external perimeter, which is 40.560. We deduct 1.100, we get 39.460. So that is the main guard for the external wall. What is the main guard for the internal partition? The main guard for the internal partition, we shall take the length 3.70 and the width 3.50. Then remember that the external walls has a spread, so it will be up to here, the spread, and the spread will be up to there. So the spread is 250 millimeters. So if it spreads 250 here and 250 here, what will be the length of the internal wall? It shall be 3.70 plus 3.5, we get 7.2. Then we deduct 0.25 multiplied by 2, 0.5. We shall get 6.7. So that will be the main guard for the internal wall. Alright, so we shall go to excavating. When you're excavating the trenches, we shall excavate trenches width over 0.3 millimeters. Alright, so the center line for the external walls, the width of the external wall, you remember it, we shall take the foundation strip, the width. Then we shall take the depth for excavation. The depth of excavation, you will take 900 plus the thickness of the concrete in the strip. Alright, for the internal partition, we shall take the center line, we multiply by the thickness of the internal wall, the strip footing, then we multiply it by the depth of the strip footing. So for all these, this will be the volume of soil where we shall excavate trenches. Then this same volume of soil we shall fill to excavation, average thickness exceeding 0.25 millimeters. You see, they are saying at this point, it is assumed that all of the trenches will be backfilled. When the concrete and brickwork are measured later, the quantities of filling will be adjusted. Yani, when we excavate the trenches, we shall assume that we will backfill using the whole of that soil. All this soil, we shall use it to backfill. We shall adjust it. So this soil, we shall add it to RFR, refill and ram. We shall adjust the volume of soil when we replace it with concrete and brickwork. So any other soil that we shall calculate, either in brickwork or concrete, that volume that will replace the soil is the one we shall deduct from RFR and add to cutaway, the soil that we shall dispose away from the site. Right, then we go to surface treatment, compacting bottoms of excavation. Bottoms of excavations, remember the whole area that we have reduced the level, we shall compact the bottoms. So that is simply the whole area that we have done reduced the levels. So we reduced the level, the length was 14 and the width was 7.28. All that area we shall go compacting the bottoms, because even if we have excavated the trenches, we will compact the bottom of the trenches. So all that area, as long as it's flat, it's a bottom, we shall compact it. So it's 14 and 7.28. Then we shall go to earthwork support, maximum depth not exceeding 1 meter and distance between the opposing faces not exceeding 2 meters. When you're supporting the earthwork, we are supporting the soil. Remember, this is clay soil, so and clay soil may collapse. So we usually support even where we have reduced the level and in the trenches. So what will be the area of the formwork in the trenches? First of all, in the trenches, we shall take the center line of the trenches. Remember, the mean girth for the external wall was 39.46. So 39.46. Then we shall support the depth of the trench, which is 1.05. All right. So we take the center line and the depth, which is 0.15. Then we shall, we support both sides of the trench. For example, if this is the trench, let me draw if this is the trench, we support this side, and we support this side. So what is the area of the formwork? We shall take the center line because it's the length, then we multiply by the depth, the area on one side. Then we shall multiply by two sides, because a trench has two sides to be supported. Then we shall take for the internal walls, it was 6.70. So this one is for the internal wall, 6.70 multiplied by the depth, multiplied by 2 for both sides of the trench. Then we shall support also where we have reduced the level. Now this one we shall calculate by taking the length where we have reduced the level was 14, the width was 7.28. So the total perimeter was 4.50. Then we have reduced the level by 150 millimeters, remember. So we shall take the perimeter, then we multiply by 0.15. So if it was a site, we shall support all the soil that is not on the ground level. We have reduced the level by 0.15, so we go round the side, then we multiply by 0.15. Then for the trenches, we take the both sides of the trench by taking the center line times the height, multiply by 2. I hope that is clear. All right. We shall proceed to measuring for the concrete in the foundation trenches. To measure for the concrete in foundation trenches, we shall just take the center line of the foundation trenches of the external wall, multiplied by the thickness of the strip foundation of the external wall. We multiply by the 150 millimeters concrete. Then for the internal partition, you take the center line of the internal partition, you multiply by the width of the spread foundation strip. Then you multiply by 150 millimeters of concrete. So this is the volume of the concrete that will be in the foundations. For that volume of the concrete, remember that we assumed that we have refilled the foundations. So that soil was taken to refill and ram. So that soil, because now it has been replaced by the concrete, we shall deduct it from refill and ram, feeding to excavation. Then we shall add it to cut away, the soil that will be disposed away from the site. All right. So to brickwork. Brickwork in the foundation, in the trenches. The brickwork, we are told that the foundation is 900 millimeters. The hard core is 150. The insulation is 0.50. The concrete bed is 100. And all these one, the height of the brickwork is taking all these height from the concrete bed to the foundation strip, because it's just coming over the foundation strip. So what is the total height? It's 1.2. The walls, we measure the brickwork in terms of area. So for the external walls, the center line was 39.46. We shall multiply by the area of the walls. All right. We shall multiply by the height of the walls to get the area of the walls. We'll take the center line times the depth of the walls. All right. So for this one, we are told walls half brick thick in common bricks, laid stretcher board in cement sand mortar. All right. So this one is the area of the walls in the external walls. Remember, in the external walls, we have a double wall and we have a gap at the center. It's called it's a double wall. So we shall multiply by 2 for the external and for the internal. So the area will be 2 because we have the area for the outer wall and the area for the inner wall because it's a double wall. Okay, then for the internal partitions, we shall take the center line as 7.2, then we shall multiply by the depth of the wall, which is 1.2. So walls in dense concrete blocks are 100 millimeters thick in cement mortar, ratio 1 is to 2, ratio 1 is to 3. So simply for the walls, we measure the areas by taking the center line times the depth of the walls. We will now go to forming cavity in hollow walls, 50 millimeters wide width and including stainless steel twisted wire wall tiles, each 5 per square meter. This is where we introduce twisted wire wall tiles inside the cavities, and also we are forming the cavity in hollow walls. So all that process of doing the cavities and including the reinforcement in the cavity, we measure it in terms of area. And when we are doing area, we will take the center line, then we shall multiply by the height of the wall. The height of the wall is 1.2. Then we shall go to in situ concrete, ratio 1 is to 12, filling to hollow walls not exceeding 150 millimeters thick. The concrete, we shall measure it in terms of volume. And actually here we have a controversy. What we have in the book is 39.46 is the 39.46 is the center line. Then we multiply by 0.08. Then we have the height of 1.15. Okay, how I know that we are supposed to do the volume of the concrete? We shall take the center line, which is 39.46. The width of the hollow concrete is 50 millimeters, so it should be 0.05. And the depth should be, we shall take the total depth of the wall, which is 1.2. We deduct to 25 millimeters because we should leave an allowance between the concrete in the hollow walls and the DPC. It should be at least a minimum of 25 millimeters. So it should be 0.95. If you have another explanation as to why it is written that we should take 39.46 as the center line. That one we agree. The width should be 0.08 and the depth should be 1.15. Kindly explain it to us in the comment section. I would also want to know. All right. Then we shall go to adjustment for brickwork in trenches. Remember that we refilled the total volume of we used the total volume of soil excavated and placed it in RFR. Now we shall take the volume that has been replaced by the walls and add it to cutaway. So the volume of the walls, we shall take the center line, which is 39.46. We multiply by the thickness of the walls. For the external walls is 0.28. Then we multiply by the height of the wall up to the reduced level, which is 0.9. For the internal wall, we shall take the total length of the wall, which is 3.5 plus 3.7. Remember in excavation, that's where we were deducting the spread. But for the walls, they have to meet the internal and the external. So the length of the wall shall be 7.2. Then we shall multiply by the width of the wall for the internal is 100 millimeters. So it shall be 0.10. Then the depth up to the reduced level shall be 0.9. All these volumes of the two walls will be deducted from RFR and we add to cutaway. All right. The other part, we shall go to reinstating the soil in the foundation spread. When we are reinstating the soil, we will be reinstating it to the ground level. We had reduced the level by 150. Now we want to return that soil outside the walls so that it can be back to like the ground level. So how do we calculate that volume of soil that we shall reinstate? That volume of soil, we shall take the center line of reinstatement, which usually is calculated by taking the external dimensions of the plan. The external dimensions, as you can see here, they were 40.56. Then when we take 40.56, we shall add number of corners times the thickness of the reinstatement. How many corners do we have? We have 4 corners. We multiply by the thickness of the reinstatement. The thickness of the reinstatement is this on the spread, which is 250. So we shall get 1. So 40 plus 1, we shall get the center line of reinstatement. Then we shall take the center line of reinstatement, we multiply by the width of the spread, then we multiply by the depth of the reduced level, because we are returning the soil to where it was. So that volume of soil, we had already cut it away. So we shall deduct it from the volume of soil for cut away and add it to RFR. Go to damp proof course not exceeding to 25 millimeters, lapped 150 millimeters at joints embedded in gauge mortar. Every wall has the damp proof course. For the external wall, we have damp proof course. It's here and it's here for both walls, the internal and the external. For the internal wall, we will have the damp proof course here. Because the damp proof course, remember, it's usually placed above the concrete to continue the walling upwards. So how do we calculate for the area of the damp proof course? The damp proof course, we shall say take the center line of the external wall, which is 39.46. Then we multiply by the area below the walls. Each wall is both walls are 275 millimeters. To 75, we deduct the cavity, which is 50. We shall get to 25. Divided by 2 walls, we shall get 112.5. So for each wall is 0.112. When we round off to 2 decimal places is 0.11. We multiply by 2 walls. Then for the internal walls, we shall take the center line, which is 7.2. We multiply by the thickness of the wall, which is 100 millimeters thick. So it shall be 0.10. Alright, so we have got the area of the damp proof course below all the. In calculating the reinforced concrete in situ, then fabric reinforcement, hardcore, surface treatment, the DPM and the 50 millimeters thick horizontal rigid sheet insulation, they lie on the same area. So all of these ones, we shall do same measurements. What is the internal dimensions of the ground floor? We shall take the external dimensions, which are 13.5. We deduct 275 on both sides, get 12.95. For the width, it shall be 6.78. We deduct 0.275. We shall get on both sides 6.23. So the internal dimensions is 12.95 and 6.23. So for all this area, we shall do the C2, the concrete. If you want to get the volume of concrete, we shall multiply by the depth of that concrete, which is 100 millimeters. Okay, then we measure the fabric reinforcement. We go to the hard coal. If we want to get the volume of the hard coal, we shall multiply by the depth. We go to surface treatment, then DPM, then the insulation. So we are told to know the damp-proof membrane and the damp-proof cores are lapped on the inner skin of the external wall. So whenever we want to measure, we will use the internal dimensions. Then now that we have measured using the internal dimensions, we did not deduct where there was the internal partitions. So we shall take the center line of the internal partitions, then we multiply by the thickness of the internal partitions. Because all that we have done, measured, it will not happen below the wall. So we shall deduct the area below the walls on the internal partition. So the center guard is 7.2 and the area of the internal partitions is 100 millimeters, 0.10. So we shall say deduct the last 6. Measure the damp-proof membrane not exceeding 200 millimeters wide. For the damp-proof membrane, it is on every wall and on the inner side. So I will highlight in red where the damp-proof membrane will be. It shall be here on the surface of the wall. Sorry, it should be straight. It should be here. We shall be here. Damp-proof membrane. It's measured internally. Okay, then we shall measure here. It shall be here. Measure here, and we shall measure here. So here there is another issue of contention. If you have anything that you can explain to us, kindly help us here. This one, for the internal dimensions, the length will be 12.95 times 2. The width shall be 6.23 times 2. Then there will be 3.5 from here up to here. That will be 3.5. Then there will be 3.6 from here, this length, and this one. Then we shall have 3.7. Now I don't know why we have 2 here in the book. Remember, I'm getting this from a book. And if you can tell us why we have 2 for the 3.7, we will appreciate. Now we shall conclude with adjustment of facings to external skin. Remember that in the section we had been told that the external skin of the wall has facings. So how do we calculate for the center line of those facings? We have the external face, the perimeter is 40.560. So we shall deduct the width of one facing so that we can get the center line of the facing. So it shall be 4 corners times 112.5, 0.112.5. So it shall be 0.45. So when we deduct, we shall get 40.110. That is the mean girth for the measure for the area of the facings. We shall take the mean girth of the facings, then we multiply by the depth of the facings. The facings are 150 millimeters above the ground and 150 millimeters below the ground. So we shall take the center line, which is 40.11, and then we multiply by 0.30. Half brick wall in facings, vertical pointed one side, and half brick wall in common bricks. We deduct a half brick wall in common bricks as above described. So we shall for the half brick wall in facings, it shall be 40.11 0.3. Then we shall deduct the same area for half brick wall in common bricks. Okay, So thanks for watching this video. It has been a bit hectic, and we have areas of contention. Kindly, it was sent to me by a student, and there are those two areas that I've said that in case you can understand maybe where they've taken those dimensions from, you could help us understand. We always live to learn each and every day. So thank you for watching, and remember to subscribe to our channel and to like our videos, and we shall continue to make more content for you. And let us share the knowledge and help each other even as you prepare for exams. So all the best in your exams, and thanks for watching.